Welcome to our show. Today we're diving into a fascinating topic: how people in the past figured out the size of our planet. Can you tell us a bit about this?
Absolutely. It's quite an interesting story. You see, measuring the Earth's circumference is like cutting a watermelon into equal slices. If you can measure just one slice accurately, you can figure out the size of the whole thing.
Wow, that's a clever analogy. But how do you actually slice the Earth? It's not like we can take a knife to it, right?
You're right, we can't physically cut the Earth, but we use something called the geographic coordinate system. If you look at a globe, you'll see it's covered with lines running up and down, and others going around it horizontally.
Oh, I've seen those. What are they called again?
The lines running up and down are called longitude lines, and the ones going around the Earth are latitude lines. If we were to cut along the latitude lines, we'd get circular slices, kind of like cucumber slices. But if we cut along the longitude lines, we'd get half circles, more like cutting an orange in half.
That's interesting. Are all these slices the same size?
Actually, no. There's a key difference. The latitude slices aren't all the same size. The ones near the middle of the Earth, its big belly, so to speak, are larger. The biggest of these circles is called the equator. But all the longitude slices are the same size, each being half a circle.
I see. So how does this help us measure the Earth's size?
Well, we have two options. We can either measure the length of the equator, or we can measure any longitude line and multiply its length by 2. Both methods will give us the circumference of the Earth.
Fascinating. Did anyone actually try to do this?
Yes. Over 300 years ago, a scientist named Charles de Norwood chose to measure a longitude line. He came up with a clever solution to make the task more manageable.
What did he do?
He decided to divide a longitude line into 180 equal parts. This wasn't random. It's because a full circle is 360 degrees and a longitude line is half of that. So each part became 1 degree. His plan was to measure just 1 degree and then multiply it by 360 to get the Earth's circumference.
That sounds smart, but I imagine it still wasn't easy. What challenges did he face?
You're right, he faced 3 main challenges. First, how could he ensure he was walking along a longitude line without veering off course? Second, even 1 degree of longitude is quite long, over 100 kilometers, which is too far to measure with a ruler. And third, how could he be certain he had measured exactly 1 degree, neither more nor less?
Those sound like tough problems to solve. How did he manage it?
Well, for the first problem, de Norwood realized that all longitude lines start at the North Pole and end at the South Pole. So by walking directly north or south, he could be sure he was following a longitude line. He could use tools like a compass, observe the sun at noon, or follow the North Star at night to keep his direction.
Clever. And what about measuring such a long distance?
For that, he used a simple but effective method. He prepared a 100-meter-long iron chain. He'd fix one end at a starting point, drag the other end northward until the chain was fully extended, then repeat the process, using each new point as a starting point for the next measurement.
That must have taken a long time. But how did he know when he'd traveled exactly 1 degree?
That's where it gets really interesting. He relied on observing the sun's height. You see, at his starting point, the sun would be directly overhead at noon. As he moved northward, the sun's position at noon would appear to shift, becoming less directly overhead. De Norwood knew through calculations how much the sun's height should change after traveling 1 degree along a longitude line.
That's incredible. Did his method work?
It did. His measurements were remarkably close to those we get with modern technology. But this discovery led to something even more interesting. Scientists realized that the Earth isn't a perfect sphere.
Really, what shape is it then?
It's slightly flattened with its equator bulging out a bit. We call this shape an oblate spheroid. If the Earth were a perfect sphere, the length of the equator would equal the length of 2 longitude lines. But measurements showed that the equator is slightly longer.
Wow, I had no idea. Why is it shaped like that?
It's due to the Earth's rotation. Imagine the Earth as a water-filled balloon spinning on its axis. The faster it spins, the more it flattens. This concept helps explain why our planet isn't a perfect sphere.
That's amazing. Who would have thought that measuring the Earth could reveal so much about its shape? Thank you for sharing all this fascinating information with us today.
It's my pleasure. The history of science is full of ingenious methods like this. It just goes to show how human curiosity and clever thinking can unlock the secrets of our world.